Well, welcome back to Hudson Engineering Academy. Today we're going to perform one lab experiment. I'm going to show you how the clay sample behaves in two different liquids, that is to say, in water and in kerosene. So these are two samples that I have put, and I've taken a clay sample. Here I have put 100 gram of clay sample, and I have added 150 milliliter of what? Of kerosene and water. So if you observe carefully, you'll find that in this sample for kerosene, it has not absorbed the water. But here it has absorbed the water and it has formed a paste as from the mixture, okay? But this one, when you mix it, even if you mix it, it's not absorbing the water. Now, first of all, before we continue, I need to tell you the behavior, how does it behave in water? So you find that this one is absorbing water while the other one is not absorbing water. Clay has a surface charge which is negative, okay? So what brings in this negative is due to what we call the isomorphic substitution reactions that takes place. You know, in clay we have a silicon, we have aluminum, but isomorphic substitutions means that if I have silicon which is having 4 plus charge, then I have aluminum which is having 3 plus charge. If the substitutions takes place, that is when isomorphic substitution is when the one with a lower valence, like aluminum which is 3 plus, substitute the one with higher valence, like silicon which is 4 plus. You remember that that one will form a negative charge. Why? Because 3 charges is going to replace the one which was having 4 charges. So 1 will be lacking. So that means it is what? Negative. Now it makes it to have a surface charge which is what? Negative. Now bringing in water, you know, water is a polar what? Water is a polar liquid. Now what makes water a polar liquid? Water is a polar liquid because one, water has what we call hydrogen bonding. And due to this hydrogen bonding in water, it makes water to be a polar liquid. Because if, for instance, I can show you water. Water is having H2O. So if this is oxygen, this is what? Hydrogen and hydrogen. Okay? So due to the bonding, it will make it to form a partial what? Here will be partially negative, but this will be partially positive, and this will be partially what? Positive. And the angle between this structure of water, this angle is what? Is 104.5 degrees. Okay? So this is the structure of water. And because of the presence of oxygen in this water, which is highly electronegative, this water will find a way that will leave, because there are 2 hydrogen, which is what? Are partially positive. So this partially positive hydrogen will attach itself to what? Will attach itself to the other negative of the clay. So making water to be absorbed into the clay and forming this kind of paste. I believe I've explained to you why water is polar. And if you try to find what? That in kerosene, it will not come. Now I want to show you the next thing is we can find the liquid what? The liquid limit of this when I use water and mix with clay. Yes, it is true. So just like in our previous video, I discussed to you how to find the liquid limit of what? Of this. It is possible, but what if you try with what? With clay? Is it possible? So let's see if we can form a groove here, okay? Let's see if we can form a groove in this experiment. Remember, when you're performing this experiment, you have to put at the center there's the depth of what? The depth of clay should be 10 mm, okay? So, but the clay should cover 2/3 of this cut, okay? So that's what you need to observe. 2/3 of this, and there should be no void. You have to remove it carefully. Okay? Well, so we are trying to see whether it is possible to form a groove in this. So you pick your grooving tool, the Casagrande tool, put it at this center, and then form a groove. Okay? So you realize that we have formed a groove, and here you can rotate this at 2 revolutions per second. 1, yes. So from this, it has formed a groove and it has been closed after 16 revolutions. Okay, so you realize that it is the same what, the same thing that we performed in the previous experiment. Okay, so here is the difference. What if I use what? I use kerosene. Okay, so what you do is you remove this one, because it is at its liquid limit. We can find it after 25 revolution. Yeah, you can find that. Okay, after 25 revolution you can find the liquid limit of this one, of this clay mixed with water. Okay, well, so when I use kerosene, clean this well. Yeah, when I use kerosene, this is my sample. Sorry. Yeah, this is my sample. So in this sample, if I try to put, okay, here, first of all, let's have the texture. So you'll find that the texture is different from this. It is not so slippery, okay? But what about in this? What about this one? This one is so slippery. Why? This is because this one has absorbed water due to the electrostatic forces of attraction in what? In water. That has caused the what? That has caused it to be polar. Okay? So let's try to see if this one is put here, can we form a groove? Okay? If this one is put here, can we form a groove? You can see the kind of sample we are having. After having this, okay, you can see the sample. I just want you to see what is the behavior. Okay, how does it behave really? Good. So this is our sample. Same amount of sample that we have. Find that it is first of all very hard to even scoop it. Why? Because there is no force of attraction in it. Okay, so kerosene is non-polar, and what makes kerosene non-polar is that its structure consists of carbon and hydrogen only, and due to the covalent bonding in what? Carbon and hydrogen, you know, it makes this non-polar, because first of all it is straight. So this is the sample that we have. If you try to form what? To form a groove there, will it form? So you find that the thing is like a liquid. Okay, it's not forming any groove. Yes, that is what I wanted to show to you. Okay, so the difference is that in water there is the electrostatic force of attraction that makes it to be polar, that makes it to attract the clay, and then what? You stick to, they stick together. Okay, but in kerosene, the kerosene is having what? No electrostatic force of attraction. Why? Because kerosene has carbon and hydrogen, and due to the weak electronegativity, okay, present here, you find that there is no possibility of it to attract together and form that, and you cannot find the liquid limit of this particular what? Mixture in kerosene. So this is the behavior of kerosene and then water with clay. Thanks so much for watching this video till the end. Please don't forget to subscribe to Hudson Engineering Academy for more of such kind of content. Thank you.